This video is going to explain to you how to graph parabolas in factored form. Okay, so I hope you noticed that this is actually right now in standard form. And yes, you could, graph it the normal way by finding the axis of symmetry, etc. But instead, we're actually going to rewrite this into factored form. And the way to do that is by factoring out that trinomial. Alright, so if you want to pause the video right now and try to do this on your own, that's awesome. Otherwise, kind of follow along with me. So I'm going to still multiply the first and last. And I'm going to try to do this quickly. Here we go. My factors are negative 2x and 3x. I get x squared minus 2x plus 3x minus 6. Then I'm going to take out my GCF, which is x in this case, and I'm left with x minus 2, plus I take out my 3, and I'm left with x minus 2. My GCF now is x minus 2, and you're left with x plus 3. Okay, now I have successfully put it into factored form. And sometimes you're going to start off in this form, in which case you're going to want to use this method. Okay, so why is factored form helpful? Well, it's actually very easy to find the x-intercept when it's already in factored form. So we haven't really been graphing x-intercepts in the past, but it's always nice to have, and you get anyway. Okay, so let's first talk about what a y-intercept is, which we've done before. A y-intercept is when x equals 0, right? Whatever y is when x equals 0. So an x-intercept, therefore, must be when y equals 0. So what I'm going to do is plug in 0 for y, and I'm going to get 0 equals x minus 2 times x plus 3. Now hopefully you're looking at this and you're saying, oh look, it's zero product property, right? I get to use zero product property to solve this equation. So I can just say that x could equal 2 or x equals negative 3, knowing that I am solving here for the x-intercepts. I'm going to plot these on my graph. So when I plot x-intercepts, I have one point here at 2, 0, and I have another one at negative 3, 0. And interesting enough, right? Because when you're graphing parabolas, you have matching points, right? You have a matching y value. There should be an x-intercept in between negative 3 and 2. And that should be my axis of symmetry. So I could actually figure out my axis of symmetry by figuring out what's in between negative 3 and 2. And you can definitely think about it or physically count, or you could just say negative 3 plus 2 divided by 2, right? I'm going to just add the 2, and I get negative 1. And if I divide that by 2, I can figure out that the axis of symmetry is actually at negative 1/2. So I can plot that point right here. Okay. And given that information, I'm going to find the vertex like I found the other vertexes. Okay, so let's see. Oh, cool. Okay, so step 3, find the vertex. Since the AOS is negative 1/2, I'm going to plug it in actually into my factored form. It's a little bit nicer, and you'll see why. So negative 1/2 minus 2, and then negative 1/2 plus 3. And that equals, and I'm going to make it into an improper fraction. So I'm going to say 2 over 1 is actually 4 over 2. and then I'm going to say 3 is just 6 over 2. And I'm going to end up with negative 5 over 2 times 5 over 2. So my vertex, actually, I'm going to put it up here, is my x value is going to be negative 1/2, and my y value is going to be negative 25 over 4. And a lot of you are confused about how to graph fractions. Well, negative 25 over 4, if I change that into a mixed number, I'm going to put it over here, is going to be negative 6, negative 6 and 1/4. So I'm going to be at negative 1/2, and I'm going to go down 1, 2, 3, 4, 5, 6 and a little bit, and I'm going to label my graph because I'm kind of estimating, so I want to make sure I put the actual point right here. And now I have 1 point and 3 points, and I can just plot it, and I don't even need the y-intercept, although it's a pretty easy point to find. Okay, so let's just quickly do that also. Y-intercept, sorry, it's getting a little bit messy. The y-intercept, again, is when x equals 0, so I can plug it into factored form, and I can just say y equals, if I plugged in 0 for x, I'm just left with negative 2 and 3, and I get negative 6, which must have been right here, negative 6. Oh yeah, because I counted, right? Negative 1, 2, 3, 4, 5, 6. Here I am. I have a matching point over here. So I have 5 points now if I wanted. And that's how you graph in factored form.